So let us try to understand how to convert angles to radians or radians to angles. Now, as I've discussed, so for example, till class 10th, you know that the temperature can be measured either in Fahrenheit or Celsius or Kelvin, and they tell you the conversion also, how to convert from Fahrenheit to Celsius, from Celsius to Kelvin. So you'll have done all those numericals in class 9th, 10th. I think class 8th is the first time they tell you about these scales. So now we will be going in class 11th. In degrees also, now we'll have two measures of degrees. The degree measure we have already done in class 10th. The new measure that we'll understand is the radians. Yeah. Now to understand radians, we'll have to look at these 3-4 slides. So the first is, okay, now this is a circle. In this circle, in this circle, this is the length of the arc. So from this to this point, so for example, I call this P and I call this PQ, a Q. So PQ, if I measure this would be the length of the arc. Are we comfortable with this? So just remember that small l is the length of the arc PQ. Avantika, are we okay till here?
Yeah.
Now radius, this line, let me call this O. So OP and OQ are the radii. Are we okay?
Yeah.
Yeah. So this is R, this is R. Now the formula that we have is that theta, the measure of angle theta, the measure of angle theta. This is the angle theta, which is being measured in radians, which is being measured in radians. Definition of theta in radian is equal to length of arc divided by the radius of the circle. Avantika, any uh, doubt about this?
No.
So this is, plain and simple that force is equal to mass into acceleration. Are we okay about this?
Yeah.
Or it is like saying that, distance is equal to speed into time. Are we okay?
Yeah.
So this is the definition that we have. This is the definition that we have that now this definition would be, useful uh, in two forms. So one form would be theta is equal to L by R and the second form would be L is equal to R theta. Avantika, any doubt there?
No.
So again, it is like saying that V is equal to IR, electricity. Potential is equal to current into resistance. So therefore, I would be equal to V by R, or R would be equal to V by I. Any problem till here?
Yeah.
So this is a new definition. This is a new definition that we have learned that theta in radians. But what is very critical is that theta is in radians. It is not in degrees. That so remember that theta, the angle is defined as L upon R, length of the arc divided by the radius of the circle. Now, once we are okay with this, we are comfortable with the definition of theta, we are okay with the alphabet L, we are okay with the alphabet R, then let us start using this. Now, if theta is equal to L upon R, this is the definition from the previous slide. Now, let me take the length of the arc. Let me take the length of the arc equal to the radius of the circle of which it is part. Avantika, have you understood?
Yeah.
So let me take, see, it is pretty simple. Let me take any random circle, any random circle. So for example, you take your compass and you draw a circle, say, let us assume 10 centimeter. Yeah. And then, using some means, you measure the length of the arc starting from, you can start from any random point. So it is not necessary that you can start from here also. So let me take like this. Let me take like this. So this would be 10 centimeter. Yeah. Now what I do is I take the length of the arc. I take a length of arc whose measure is 10 centimeter. So this measure is 10 centimeter. Avantika, are we comfortable till here?
Yes.
Okay. So this is 10 centimeter. This is the length of the arc. This is the length of the arc.
Hmm.
So PQ. Now this PQ, this arc, is subtending an angle theta at the center. This angle theta. Are we okay?
Hmm. Yeah.
Now we know that this angle, if this angle is measured in radians, this can
Hmm.
also be measured in degrees, but we are not now measuring the angle in degrees. We are measuring the angles in radians.
Radians.
Theta in radian would be equal to, by the definition of theta in radian, the definition that we have is L upon R.
R.
Now,
Hmm.
in this case, the length would be 10 centimeter and the R would be 10 centimeter.
10 centimeter.
Therefore, this would be 1
1
radian.
radian.
Any doubt?
No.
So you can try to do this very small exercise that you can do, that
Hmm.
if you measure this now,
Hmm.
you know, within the next 10-15 minutes, you will understand that 1 radian is equal to 57 degrees. So don't worry about that, approximately 57 degrees. But try to
Hmm.
do this after the lecture. Just draw a circle of any radius.
Hmm.
Take a length of arc, and whatever angle that is being subtended at the
Hmm.
center, that
Hmm.
is that is 1 radian. And if you actually measure it using protector, this would be approximately equal to 57 degrees. Avantika, are we clear till here?
Hmm. Yeah.
And the comfort that I am giving you is you can draw any circle of any radius that you want, 10
Hmm.
centimeter, 15 centimeter, 20 centimeter, 5 centimeter. Just
Hmm.
take the length of the arc to be equal to the radius of the circle that you have drawn. And
Hmm.
the
Hmm.
angle
Hmm.
subtended by the arc at the center of the circle would be 1 radian or approximately 57 degrees. Are we clear till
Hmm.
here?
Yeah.
So the comfort that I am giving you is, for example, you will take a angle of say, you take a radius of say 20 centimeters, and you draw a circle like this. You
Hmm.
draw a
Hmm. Hmm.
circle like this. Again, when you measure, when you measure,
Hmm.
when you measure this this
Hmm.
arc, when you measure this arc, if the radius is 20 centimeter,
The arc should also be 20 centimeter.
the arc should also be 20 centimeter. Have you got the logic?
Yeah.
Similarly, if the circle was of 5 centimeter and you draw a circle like this, so
Hmm.
I'm guaranteeing you that this length of the arc would be 5 centimeter.
Hmm.
Avantika, are you clear till there?
Yeah.
Okay, great. So now you would have understood that if L is equal to R, if L is equal to R, then theta in radians is 1 radian. Are we
Yeah.
clear till here now?
Yeah.
Now the short form of radian is RAD, rad, or
Hmm.
there is a small c that you can write on any alphabet, any number, which is the measure of the angle. So, for example, if you want to say write 5 radian, you can write it like this. You want to say write 6 radians, you can write it like this. Any doubt till here?
No.
Usually, I'll be writing like this 5 radians, or I'll be writing like 6 radians.
Hmm.
You
Hmm.
can
Hmm.
follow this. It is your wish, whatever you want to follow. Okay.
Hmm.
Now, what we have understood is that if the arc is of the length which is equal to the radius of the circle of which the arc is the part, then the
Hmm.
arc will subtend an angle of 1 radian at the center.
Yeah.
Okay, till here.
Hmm.
Now let me take the arc. I'm applying unitary method here. I'm applying unitary method.
Okay.
This is unitary method.
Hmm.
Now, if I take the length of the arc to be equal to 2 pi r, why 2 pi r? Let me take 2 pi r, just like that. Yeah. If I take the length of the arc to be 2 pi r, then the angle that this length of arc 2 pi r subtending at the center of the circle would be equal to 1 upon r into 2 pi r. Avantika, any doubt till here?
No.
Okay. Now, If I solve this r and r will cancel, and the angle which is subtended at the center of the circle by an arc whose measure is 2 pi r is equal to 2 pi radian. Avantika, any doubt?
No.
Okay. Let us try to look at this graphically. What does this mean? What does this line mean? This line means that if the length of the arc is 2 pi r,
Mm-hmm.
then the angle which is subtended at the center of the circle, the angle in radians which is subtended at the center of the circle is 2 pi radians. Are we comfortable? Avatika, are we comfortable?
Yeah.
So the angle would be equal to 2 pi radians. The length of the arc is 2 pi r. 2 pi r subtends 2 pi angle, 2 pi angle at the center.
Mm-hmm.
Pi angle, 2 pi radian at the center. Are we comfortable, Avantika?
Yeah.
Now, why the length of arc was taken to be 2 pi r, I hope you will understand now, because the 2 pi r length, 2 pi r length, from
Mm-hmm.
here to here, this is the circumference
Circumference. Yeah.
of the of a circle. Any doubt
Circle.
in it?
No.
So 2 pi r length subtends 2 pi radians at the center. Avantika, are we okay till here?
Yeah.
But we also know from previous classes that this whole, in terms of degrees, is 360 degrees.
Hmm.
So 360 degrees would be equal to 2 pi radians. Avantika, any doubt?
No.
Now, this is the magic thing that we were looking for. This was the conversion factor that we were looking for. Like in temperature, we used to have
Okay.
conversion factor. So now
Mm-hmm.
we have got hold of the conversion factor. And once we are comfortable with the conversion factor, then
Hmm.
what we can understand is 180 degree would be pi radians, 90 degree would be pi by 2 radians, 270 degree
Mm-hmm.
would be 3 pi by 4 radians. So basically,
Okay.
what we have understood is that, you know, I'm sorry,
270.
270. So what we have understood is that from the world of degrees,
Hmm.
we are now in the world of radians.
Hmm.
This is one thing I need to.
No.
Okay. Now this would be a bit tricky initially, but once we have practiced enough questions, we'll be able to do that. That
Mm-hmm.
won't be much of an issue. So basically, slowly we'll have to get convergent with the 30 degrees, 45 degrees, 60 degrees, how to write that in terms of readings. Have you understood?
Hmm.
Because all the calculus will work in terms of radians. It won't work in degrees. Have you understood?
Okay. Yeah.
The main problem that you'll start facing, once you start getting into day-to-day physics, etc., the calculator that you'll be using, the calculator.
Hmm.
See, CBSE CBSE, ISC, Maharashtra board, they do not let you use calculators in the
Hmm.
exams. But while practicing the problems, you will be using calculator.
Mm-hmm.
So when you will be using calculator, when you start doing the numericals in degrees, in
Mm-hmm.
angles, the calculator will be giving you an option that do you want the angle to be in radian or you want the angle to be in degrees. So you will have to
Mm-hmm.
always change the setting. Have you understood what I'm saying?
Okay. Yeah.
That will discuss. How to change that, that will discuss. Don't worry about that. But
Hmm.
the point is that, in this lecture, our world of angles has expanded from degrees to radians. Are we
Hmm.
comfortable in this new world?
Yeah.
Great. So, this is what the conversion is in the slide 2. This is how the conversion looks like. And as promised, because pi radians can be written as 180 degree. So 1 radian can be written as 180 degree upon pi, approximate value of pi. Have you understood what I've done? Avantika, have you understood what I've done?
Yeah.
And once you divide 180 degree by 3.14, you can take this 3.14 or 22 by 7, whatever you want. Uh, the approximate value would be 57 degrees. So our conversion that we should remember is that 1 radian is equal to 57 degrees.
Okay.
Any doubt in that?
No.
Now, in one of the lectures, not in this lecture, because then a lot of new stuff would be crammed in one lecture. In one of the separate lectures, what we will understand is that the degree can be subdivided into minutes and seconds. And these minutes and seconds, they are not the minutes and seconds of the time that we are using. Have you understood what I've said?
Yeah.
Basically, what I've said is that if this is 1 degree, this 1 degree can be further subdivided into minutes, and the minutes can be further subdivided into seconds. Have you understood what I've said?
Yes.
See, Avantika, uh, I'll just give you a very small example. I won't go into the details, but I'll just give you a very small indication. So, for example, if you are a pilot or you are a person who is in charge of the ship, now this 1 degree, if it is extended to say 1,000 kilometers, will end up making a lot of difference in the distance. Have you understood what I've said?
Yeah.
So that is why you want very accurate angles. So that is why this 1 degree is further divided into 60 minutes, and those each minute is divided into 60 seconds, because you want the measure that needs to be given to a plane pilot or a ship pilot has to be very accurate. I will just stop here. I will not go into further detail, but this is something that we'll discuss in one of the lectures.
Okay.
Because in this lecture, I want to limit myself to just the conversion of degrees to radians. That is it. This is a separate lecture. We'll
Okay.
have a separate lecture about this. So, are we comfortable with the conversion?
Yeah.
Basically, in the last 15-20 minutes, all that you have understood is one simple thing. If you want to understand just one thing and skip the rest, the only thing that we have learned is that 2 pi radians is equal to 360 degrees. That is it. That is it.
Hmm.
Any
Yes.
doubt till here?
No.
Okay. Now, I think now things will start making sense to you. So, for example, if I have to solve, if I have to solve this question, 80 degrees, convert this 80 degrees into radians. So, 360 degree is equal to 2 pi radians.
Hmm.
Yeah. So, 80 degrees would be
Yeah.
equal to 2 pi upon 360 into 80 radians. And please leave the answer in fractions. In fractions only.
Okay. No decimals.
No decimals required. Are we comfortable?
Okay.
In fractions only.
Yeah.
That is it.
Mm-hmm.
I will try to send you the answers. If there are answers available, then I will send you the answers
Hmm.
also. But please limit the answers are available. So please limit the calculation to fractions only. Any doubt till here?
Okay. No.
So similarly, Avantika, any doubt till here?
No. No. No.
So 2 pi radians is 360 degree. And if I have to do, say, for example, 3 pi radians, then 3 pi radian would be equal to 360 upon 2 pi into 3 pi would be equal to pi and pi will cancel 2180,540 degrees. Avantika, any doubt?
No.
Yeah. So I will send you the answers also. The answers are available. So we'll have to do question number 1, question number 2, Question number 5. Question number 5. 1 to 5 only. Try to do. Do you have the scientific calculator with you?
No, no, I don't have that.
Okay, not an issue. Not an issue. So skip question number 6. No worries, no problem.
Okay.
We don't require the scientific calculator now. So this is what I was telling you, that this is the second formula, but you know, the same formula that is being written in another form, that if theta is equal to L upon R, then L is equal to R theta. Same formula. So for this formula, you can practice these questions. Question number 1, question number 2. These are the two questions that you can practice.
Okay.
How do you get it out?
No. Is it okay if you can just do can you go to the exercise number 2 again?
Yeah.
8.1 second.
Yeah. Yeah. Yeah, Vandhi. Yeah.
And also on 5 and 6. I want a question number 2. Yeah. Can you just show again, change these angles to degrees once again?
Question number 1 or question number 2?
2.
Question number 2. Okay. Okay. Let's see this
Yeah.
again. Okay. Let's see this again. So for example, let me do pi by 9. Pi by 9. So for example, 2 pi radians is equal to 360 degree. Are we comfortable?
Yeah. Yeah.
So let me take another step. Then 1 radian would be equal to 360 degree by 2 pi. Are we comfortable? Are we comfortable?
Yeah.
This is just plain unitary method I'm using.
Yeah.
Therefore, pi by 9
Yeah.
radian would be equal to 360 degree by 2 pi into pi by 9. So, pi and pi cancels. 9 to the 18, 18 to the 36. So, this would be equal to 20 degrees. Any doubt?
Okay. Yeah.
Any doubt?
No.
Let's do another question. The first two steps in all the questions would remain the same. Have you understood the logic?
Yeah.
The first two steps in all the questions would remain the same. Now I can take any other question. So for example, let me take 6 pi by 5. Yeah. So 6 pi by 5 radians would be equal to 360 upon 2 pi into 6 pi by 5. Any doubt?
No.
So again, same steps. There's a cancellation here, and there is a cancellation here. 5, 7 to 35, 72. So this would be 216 degrees. Any doubt?
No.
Okay. So let me take just another example so that you are comfortable. Now let me take. Now let me take. Let me take 7 pi by 10. So 7 pi by 10 radians would be equal to multiplied by 7 pi by 10. So pi and pi cancels, 0 and 0 cancels. 2, 18 the 7, 8 the 56, 126 degrees. Any doubt?
Okay. Yeah.
Any
No.
doubt? Yeah.
Now it makes sense.
You'll be able to manage.
Yeah.
So let's meet tomorrow. I'll be uploading this lecture in the next 2 hours or so. Yeah.
Okay.
So you can refer to this lecture, and any doubt that you have, we can discuss it.
Okay.
Any other doubt?
No.
Okay. Let's meet tomorrow at 11. Yeah.
Okay.
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 Yeah.
Thank you. Bye.
Yeah. Thanks. Bye.